Ever wondered how software systems are designed to be maintainable and scalable? It's not just about the lines of code or the algorithms used. It's about the relationship between the components within the system. Two key principles come into play here: cohesion and coupling. They're the secret ingredients that make a software system robust and efficient. And they're not as complicated as they sound. So, are you ready to delve into this fascinating world? Stay tuned to discover the secret sauce of software design, cohesion, and coupling. First things first, let's understand cohesion. Cohesion in the realm of software engineering is a measure of how closely the elements within a module or component are related to one another. Think of it as the glue that holds the parts of a module together. It's all about the degree of unity, harmony, and coherence within a module or component. Cohesion is not just a fancy term, it is a key principle for designing software systems that are maintainable, scalable, and understandable. It's about making sure that each component or module in your software system does one thing and does it well. Now, why is this so important? Well, high cohesion can make a software system easier to understand, easier to maintain, and less prone to errors. It ensures that each module or component has a single, well-defined responsibility. This makes it easier to understand what each part of the system does, which in turn makes it easier to make changes, fix bugs, or add new features. On the other hand, low cohesion can make a software system more complex, harder to understand, and more prone to errors. If a module or component tries to do too many things at once, it can become difficult to understand and maintain. It can also lead to duplication of code, where different parts of the system are doing the same thing in slightly different ways. This can make the system more fragile, as changes in one place might unintentionally affect other parts of the system. So, when you're designing a software system, you should strive for high cohesion. This means making sure that each module or component has a single, well-defined responsibility. It means making sure that all the elements within a module or component are closely related and all work together to achieve a common goal. Remember, high cohesion is a desirable attribute in software modules. It's like a well-rehearsed orchestra, where each instrument plays its part perfectly, contributing to a harmonious and beautiful symphony. So, keep the principle of cohesion in mind when you're designing your next software system. It will make your life a lot easier, and your software a lot better. Cohesion comes in different flavors, each with its own characteristics. Let's begin with functional cohesion, the crème de la crème of cohesion types. In this case, all elements within a module contribute to performing a single specific task. Imagine a module in a payroll system, solely dedicated to calculating employee salaries. Each element within that module focuses on the same goal, making it functionally cohesive. Next up, we have sequential cohesion, where elements in a module are lined up like dominoes. The output from one element acts as the input for the next. Consider a module in a baking recipe app. One element might retrieve a recipe, the next calculates the needed ingredients based on the number of servings, and the third formats the recipe for display. They follow a sequence but are doing different tasks, hence sequential cohesion. Communicational cohesion is up next. This unfolds when elements operate on the same input or produce related output. Let's think about a module in a weather forecasting app. Multiple elements might work on the same weather data to calculate temperature trends, humidity levels, and wind speeds. They're all communicating about the same dataset, hence the term. Next in line is procedural cohesion. Here, elements are grouped based on their execution order or procedural flow. Take a module in a game, for instance. One element might handle the user's input, the next updates the game state, and the last one renders the new state on the screen. They're not necessarily related by task, but by the order in which they execute. Finally, we have temporal cohesion, where elements within a module are executed at the same time, like clockwork. Think of a module in a computer system that starts up various services when the system boots up. Each element might perform a different task, but they all spring into action at the same time. Each type of cohesion has its own place and use in software design. Understanding these different types is key to designing software that's maintainable, scalable, and just plain makes sense. Moving on from cohesion, let's explore the other side of the coin, coupling. If you think of any machine, be it a watch or a car, every part is connected to another in some way, right? The same concept applies to software systems, where the parts are referred to as modules or components. The way these parts connect and interact with each other is what we call coupling. Now, why is coupling important in software engineering? Well, it's all about interdependence. Coupling measures the degree to which modules or components within a software system are interdependent. In simpler terms, it's about how much one part of your software relies on another to function. Imagine a scenario where you need to change something in your software. If the part you're changing is heavily coupled with other parts, those parts could also be affected by the change. This can lead to a domino effect, where changing one thing leads to having to change many things, which can be time-consuming and error-prone. On the other hand, if the part you're changing is loosely coupled with the rest of the system, you can make your changes without worrying about unexpected consequences. This is why, in software design, we strive for low coupling. Low coupling means that modules are relatively independent. They can be changed or modified without affecting other parts of the system. This independence makes your software easier to maintain, more flexible and less prone to bugs. But don't be fooled into thinking that low coupling means no interaction. Even in a low-coupled system, modules need to interact to achieve the overall functionality of the software. The trick is to find a balance where the modules interact in a way that they can still remain independent. In contrast, high coupling suggests that modules are tightly interconnected. This makes your software harder to maintain and modify because changing one module could impact others. So, to sum it up, coupling is all about how much one part of your software relies on another. It's a measure of interdependence. And in software design, we strive for low coupling to maintain the independence of modules. Just like cohesion, coupling also has its own varieties. Let's dive into the two main types of coupling: content coupling and common coupling. Picture these concepts as the ties that bind different parts of a software system together. First, we have content coupling. This type of coupling is like having a nosy neighbor who's always peeking into your house, trying to find out what you're up to. In software terms, it happens when one module directly accesses or modifies the internal data or workings of another module. It's like one part of your program saying to another, "Hey, I'm just going to borrow this piece of data, don't mind me." This is generally seen as the most undesirable form of coupling because it creates strong dependencies between modules and can cause a domino effect of issues if one part needs to be changed. Next, let's talk about common coupling. This type of coupling is like a communal kitchen in a shared apartment. Everyone has access to it, and they all use the same appliances, cutlery, and occasionally ingredients. In the world of software, it happens when multiple modules share the same global data or state. While this might be necessary in some cases, just like a shared kitchen is essential in a flat share, it can lead to a myriad of problems. If one module changes the shared data, it can have unintended side effects on all the other modules that use the same data. Just like if someone uses up all the milk, it affects everyone else's breakfast plans. So why does understanding these types of coupling matter? Well, the more we know about how different modules in a software system interact with each other, the better we can design and maintain that system. It's like understanding the dynamics of a team. Once you know how everyone works together, you can make more informed decisions about how to coordinate and organize them. Understanding the different types of coupling helps in designing better and more maintainable software systems. So, keep these concepts in mind the next time you're working on a software project. They might just save you from a lot of headaches down the line. Let's recap what we have learned today. We delved into two pivotal principles of software engineering: cohesion and coupling. Cohesion, you'll remember, is about how closely the tasks and responsibilities within a module are related. High cohesion means elements are focused on a single task, increasing understandability and maintainability. We explored functional, sequential, communicational, procedural, and temporal cohesion, each representing different degrees of task relatedness. Then, we navigated the waters of coupling, which measures the degree of interdependence between modules. Low coupling, the more desirable state, means modules are independent and changes can be made without affecting others. High coupling, on the other hand, suggests tight interconnections, making modifications a trickier task. We examined content and common coupling, each posing its own challenges and potential issues. Think of cohesion and coupling like a dance duo. Cohesion is how well one dancer performs their routine, while coupling is how much that routine depends on their partner. The ultimate goal is to have each dancer perform a flawless solo routine. but with a shared rhythm that brings them together in perfect harmony. Remember, a well-designed software system exhibits high cohesion and low coupling. Keep these principles in mind the next time you design a software system.